All right, as we begin today, going to start with practice exercise number 70, practicing with more probability questions. Remember, probability is a ratio of how many things you want to happen, how many chances there are, I could say, that that good thing happens, compared to how many total things could occur. So you're going to practice with this, and you're going to need to put a little bit of extra thought into these problems. So exercise 70, go ahead and get started. I'll give you a few minutes to work on these. Just another minute to work on these, and then we'll go over them together. let's go and take a look at these together. And Quentin, you were first. It says, what is the probability that any two numbers chosen at random from this group, 1, 2, 3, or 4, has a product greater than 6? Okay, we're exercise 70. You did the wrong exercise.
Yeah.
Which one did you do? Well, fortunately, this wasn't graded. All right, Jamie, we go to you. What is the probability that two numbers chosen at random from that group, 1, 2, 3, 4, would have a product greater than 6?
1 to 3.
1 to 3. How many had 1 to 3? Okay, let's talk about it. We've got 4 numbers. We could pair them up 1 and 2. We could pair them up 2 and 3. We could pair them up 3 and 4. We could pair 1 with 3. We could pair 1 with 4. We could pair 2 with 4. There are no other pairings available, right? That's all the different ways in which you could pair the numbers together. How many different pairings are there, class? 6. So there's 6 different ways you could pair the numbers, correct? Now, of those 6 ways, how many can give you a product greater than 6? Well, not 1 times 2, not 2 times 3. Hey, 3 times 4 could work, right? Is there another pairing that could give you a product greater than 6? 2 times 4. But not 1 times 4 or 1 times 3. So of the 6 pairings, 2 would work. So that gives us a 1 to 3 chance that if you pick any 2 numbers at random, you get a product greater than 6. Does that make sense now? Yeah. All right, so for the next one, now we've got a set of 1 through 5. Obviously, that means there's going to be more pairings, right? There were 6 pairings before, now there's 7. Now there's 8. Now there's 9. Now there's 10. Did I get all of them? Let's see, 1 goes with 2, 3, 4, and 5. 2 goes with, obviously, 1 already. 3, 4, and 5. 3 goes with 4, 5, and of course 2 and 1, and 4 goes with 5. So let's see, that's 4, 5, 6, 7, 8, 9, 10 different pairings we could have. What was the probability that if you pick any 2 numbers at random, Jamie, you'll get a product greater than 12?
1 to 5. 1
to 5. Again, the 4 to 5 and the 3 to 5 pairings give you a product greater than 12. No other pairings would. 2 to 10, 1 to 5 chance. Does that make sense? And I assume if we missed the first one, we also missed the second, but does it make sense how to think that through? All right. By the way, that's the type of question you might see on standardized testing at the end of the school year. And that's kind of just how to think it through, is just pair them together. How many pairings are there? And again, the easiest way is start with 1. Pair 1 with everything. Now, you don't have to worry about going back to the 1, but from there, pair the 2 with everything. Okay, now pair the 3 with everything. Well, there's not much left. And then pair the 4 with the last thing. Would be a way if you want to do a systematic approach. All right, a little bit more straightforward problem. If 21 students write their names on pieces of paper, put them in a hat, what is the probability the first student who draws will draw his own name? Jamie?
1 to 21.
Good, there's 21 names in there. 1 to 21, we all should have had that one, correct? 1 to 21, you still missed it.
I changed it.
Okay, does it make sense? All right, now that assumes that he's honest about the draw, right? It's not one of those he has an extra piece of paper just kind of folded up in his hand, creased in that little crease there. All right, let's reach in and grab, lets it fall into his fingers. Hey, I got my own name, this is awesome, I win the prize. Anyway, all right, suppose a monkey types at a typewriter with only 26 capital letters on the keyboard, which doesn't exist, and types 1 letter. What is the probability the monkey will type the letter M? Jamie?
1 to 26.
1 to 26. How many also had 1 to 26? So again, those last 2 really straightforward. The first 2 required a little bit more thought, but does it make sense how to think that through? All right, so great job, Jamie. There's the candy I tried to give you last time. You wouldn't take it. My bad last time. Go ahead and pass those forward if you would, please. And take out your homework. Turn your textbooks to page 178. Page 178 in your textbooks. And I had you try 3 problems for homework last night. I say try because I wanted you to see if you could figure out what you were doing based on just the reading that you did. Okay? So not a normal procedure for me, but I wanted to give you that opportunity. You read last night about something called a compound locus. Or compound loci, going plural there. The basic idea is, if you would put this in the terms definitions section of your notebook, so you want to also have your terms definitions section of your notebook. Compound locus, very simply, refers to the point or points of intersection. Compound locus refers to the point or points of intersection of 2 or more loci. A compound locus simply refers to the point or points of intersection of two or more loci. Put a star with this. This isn't part of the definition, but it's an important fact to get down with the definition. You must think of every conceivable possibility. You must think of every conceivable possibility. This is where the thinking skills begin to come into play. This is where your mental development continues to be worked. Something that we hadn't really considered before. This is a side of your brain we didn't get to work in proofs. Really? This is your one shot to work on it, is thinking of, but how else could it have gone? How else could this go? Is there another way I could do this? Really great at expanding your brain in a number of ways. So a very beneficial section we'll spend just a couple of days on before moving on. So a compound locus, again, refers to the point or points of intersection of two or more loci. Put a star next to this. You must think of every conceivable possibility. Some problems will be very open-ended. There won't be a lot of restrictive details, which gives you the freedom to think of more possibilities. Other times, important details may be added that may restrict the way in which a picture or sketch could be drawn. So I'm going to see how we might have done on these. I want to point out, first of all, the example problem you should have observed in your reading. I want to point out the example problem at the top of page 178, which you should have observed in your reading. Go ahead and read the example problem just above the sketch. Quentin?
Locate all points that are equidistant from two parallel lines A and B, and a distance D from a given point B.
Do you see that there are two loci? I want you in your textbook to underline equidistant from two parallel lines A and B. Go and underline that statement. Equidistant from two parallel lines A and B. That's your first locus. So notice in the book what they did. They drew two parallel lines. They called them A and B. And they found the locus of points. Well, what is the locus of points? Equidistant from two parallel lines, class. A straight line. Always start with the shape. It's going to be midway between them, and it's going to run parallel to them. So we're going to draw a third straight line parallel to the given lines midway between them. That's the first locus. Now, do you see where it says and? Circle the word and. This separates our second locus. The second locus I want you to underline is a distance D from a given point P. A distance D from a given point P. Now notice where they put the point P. They put the point P right there. And if you were to find the locus of all points, a given distance from a given point, class, your locus is going to be a circle having the given distance as radius and the given point as center. So I should draw a circle with that radius. Now, class, I want to point out, as the book did, there are an infinite number of points that satisfy that first locus, aren't there? Within this line, there are an infinite number of points. Within this circle, there are an infinite number of points. So the first locus, a whole bunch of points satisfied. Second locus, whole bunch of points satisfied. But how many points satisfy both loci? How many points are both equidistant from two parallel lines and the given distance from the given point P? 2. That one and that one. So 2 points satisfy the locus. But only if you put the point P there. What if the point P were down here? Well, again, thinking of every conceivable possibility, the book didn't say where point P was going to be. So I could put point P down here. Here's your given distance. What's the locus? Well, it's that circle with the given point as center and the given distance as radius. That's a terrible circle. How many points now? None. Infinite satisfy the first locus, infinite satisfy the second locus, but if your point P falls out here, no points satisfy the locus. So you could get no points that satisfy both loci, or you could get 2 points that satisfy both loci. Any other possibilities?
Above.
What?
Above would be 0 to.
Right, if you were to put the point up here, so, well, I say that, I mean, you could put the point up here and still get a pointer point that satisfies if the distance were bigger, right? And if the distance is this big, then maybe we get 1 point that satisfies. Can we think of any other possibilities?
Can you put the point on one of the lines?
If I were to put the point on one of the lines, now again, it depends on the distance. If the distance is small, nothing still. If the distance is just halfway the distance to the other line, I still get 1. If it's any bigger than that, I still get 2. Is there anything other than 0, 1, or 2 points? No, because a straight line could miss a circle, a straight line can be tangent to a circle, or a straight line can be a secant to a circle, but a straight line can never cut a circle at more than 2 points, right? So these are all the conceivable possibilities. Now, again, there's an infinite number of ways to show misses, right? I mean, just think softball in PE. Think of the bat as being a line. Think of the ball as being a circle. There's an infinite number of ways in which the circle could miss the line. Technically, there's an infinite number of ways in which a circle, depending on where you put the P and what the D for distance was, there's an infinite number of ways that the circle could be tangent. There's also an infinite number of ways in which the circle could hit twice. But those are the only 3 numeric possibilities that exist. Does that make sense? And that's what we're doing. Hopefully, you picked up on that in the reading. How many as I'm going over it, like, yeah, that's what I got from the reading. Okay, Jamie's like a little bit, Quinn's a little bit, I kind of got that. Okay, so we need to maybe work on our comprehension a little bit, but that's okay. Let's take a look then at the homework, and as we're going over it, be thinking, how could I modify my homework just a little bit here? So, homework number 1. Go ahead and read it for us if you would, Genesis.
Locate all points within a given angle that are equidistant from the sides of the angle and also equidistant from 2 given points in one side of the angle. How many points will there be?
All right, I want you to circle the words "and also." And also. Let's circle the word "and also." That's going to separate your 2 loci. Genesis, I'm going to go back to you. Just the first locus, what do I need to draw?
Angle.
Okay, I need to draw some angle. Now, does it tell me how to draw the angle? No. So I could draw an acute angle, I could draw a right angle, I could draw an obtuse angle, I could draw a straight angle, I could draw a reflex angle, I could draw a paragon, maybe. There's a whole lot of different angles I could draw, right? Which one do you want to start by drawing? And we may draw other angles as we go, but let's start by drawing an acute angle. All right? And with our angle, the first locus was to locate all points that are
Within a given angle.
okay, within the given angle. So points out here are excluded, correct? Okay, so within the given angle, but is it any point within the angle?
Equidistant from the sides of the angle.
Equidistant from the sides. Genesis, this should be memorized. What is the locus of points equidistant from the sides of an angle? The angle bisector. Now, the reason they specify within the angle class is there are some who would argue that the line even extended back through would also be equidistant from the sides of the angle because the sides could potentially be extended this way. I'm not real picky, but here it makes it very clear it only wants the angle bisector going this direction. There's an infinite number of points here, correct, class? That satisfies 1 locus. But now we're going to add a second locus, which is why we call it compound. It's just like a compound sentence in English. 2 complete thoughts, joined by a comma coordinated conjunction, semicolon, or anyway, you get the idea. Or period, capital letter, which means they wouldn't be joined. But anyway, so second locus was what, Jamie?
Equidistant from 2 given points on one side of the angle.
All right, equidistant from 2 given points. All right, what is the locus of points equidistant from 2 given points, class? Perpendicular bisector, the line segment joining those points, correct? But I can't put the points anywhere. Remember the example I showed a moment ago? That point could be anywhere. That distance could be anything. But Jamie, where are those 2 points?
The intersection of the 2.
Now, where are the 2 points? It says right here. Also equidistant from 2 given points
on one side of the angle?
in one side of the angle. Now, you could put it up here to your 2 points, or you could put them down here. But it's very clear your points have to be in one side of the angle. Let's just put them here. We said, what's the locus of points equidistant from 2 given points, class? Perpendicular bisector. Now, based on the way I drew the picture, although there's an infinite number of points that satisfy the first locus, infinite number of points that satisfy the second locus, how many points satisfy both loci, class? 1. What if we'd drawn an obtuse angle and then we put our points maybe in this side. Now how many points satisfy both?
One.
Still one, because you realize, of course, lines can be extended indefinitely, so still just one. What about a reflex angle? Okay, so there's reflex angle. And we put the points here.
0.
Now because it says within the angle, now we would get 0. So we could get 0 points or we could get 1 point. What about like a straight angle? What does the angle bisector of a straight angle look like?
Right angle.
Yeah, it's going to form the right angle, right? It's going to be a perpendicular. So when I put 2 points in one side of the angle and draw the perpendicular bisector, also 0. But that's not a new number, right? It's just another way to get nothing, right? But it's not new.
I don't think you did. Okay.
Right, well, let's think about this. 2 lines. How many times can they intersect?
1.
At most once. They could miss and be parallel. They could miss only because this segment ends here, or the ray rather ends here, right? But certainly the parallel indicates we would get nothing. There is one other possibility for 2 lines. They can't cross a second time unless they actually were to coincide. Then how many points of intersection will we get? Infinite. Is there any way to get the angle bisector and this perpendicular bisector to coincide?
If the 2 points were, if the angle bisector was in between the 2 points?
Right, but in order for the angle bisector to be between the points, 1 point would be in one side of the angle and the other point would be in the other side. I think what he's saying is this: if your 2 points were like here and here, then your perpendicular bisector would be on top. But notice it said both points were in one side, not a point in either side. So because of the way the book restricted where we could put our points, the infinite possibility doesn't exist. That's the only way it could have been, right? Is if they were on separate lines and the perpendicular bisector ran on top. So infinite is not an option here. 0 points or 1 point. Is it beginning to make more sense now? All right, good. All right, let's take a look at number 4. And Ethan, read that one for us.
Okay, all points that are equidistant from 2 given parallel lines and also equidistant from 2 given points on one of the lines.
All right, so the first locus, Ethan.
Two parallel lines.
I draw 2 parallel lines, but what's the actual locus?
A line midway between in the middle.
Okay, equidistant from them means a third line parallel to them, midway between them. So there's locus numero uno. Don't know why that curved. All right, what's the second locus here, Kendall?
Equidistant from 2 given points on one of the lines.
Right, and we just did equidistant from 2 given points, and once again, do you see the book restricts where we can put our points? They have to be on one of the lines. So, does it really matter how close or how far apart they are, class?
No.
I mean, regardless, I'm going to have to draw for my locus class the perpendicular bisector. How many points satisfy both loci, class?
1.
1. Is there any other way we could draw this? Is there any way this perpendicular bisector could miss?
No, that's beyond the line.
Because they have to be on the line, the points have to be on the line, then this has to be perpendicular to that line, which means it also has to be perpendicular to the parallel and to the parallel locus. And so they have to intersect, so we have to get at least 1. And there's no way it could coincide because it has to be perpendicular. So, based on what we know of geometry, this is the only possible solutions. You would get 1 point. Does that make sense?
Mm-hmm.
Continuing to understand this maybe a little bit better even as we go. All right, good. All right, because I'll give you a chance to try some new ones here in just a moment. Well, let's drop down to the last one that you attempted for homework. Number 9, Audrey, read it for us.
Locate all points that are equidistant from 2 given points and also equidistant from the sides of the given angle.
Do you see that this is virtually the same thing as number 1? Look at it. Number 9, equidistant from 2 given points, equidistant from sides of angle. Look at number 1, equidistant from sides of an angle, equidistant from 2 given points. There's only one difference. Do you see it, Audrey? They're virtually the same locus, but there's one very important phrase missing. Actually, it's two phrases, but two prepositional phrases.
From the sides.
Well, that's what it says in the first one. Look at all points that are equidistant from the sides of the angle. Here's from the equidistant from the sides of a given angle. Jamie?
One of them is on the 2 points on one side, the other one it says from the sides of a given angle.
Well, equidistant from the sides of the angle. Equidistant from the sides of the angle. That statement's in both. In number one, where did the two given points have to be?
On one side.
In one side of the angle. In number 9, where are the two given points? It doesn't say. So you see, the only difference between 1 and 9 is I can put those 2 points anywhere I want. So once again, equidistant from sides of angle just means Audrey angle bisector. But I get to pick where my 2 points go. Well, Audrey, where might we put our 2 points? Maybe way out here? And if I did that, of course, equidistant from 2 given points is going to be that perpendicular bisector. How many points satisfy both loci, class?
0.
1.
1.
Because remember, lines can be extended indefinitely. They would meet somewhere up there. So I could get 1. Now, it would be better for me to draw it like this, so I can actually see the intersection. Okay, so when you're drawing your loci, draw it so we can actually see the intersection. But even if you put them out here, you'd still get 1. Are there any possibilities, Audrey, besides 1 point? Ethan?
Yes.
What? Okay, give me an example.
Turn the line, put the 2 points below the angle, and yeah, like so.
Well, okay, I see where you're going with this. Now again, some geometry people would argue that this line could also be extended, you still get 1 point.
Then have it to where it's parallel.
Ah, there we go. That takes all the question out, right? If I were to pick my 2 points so that my perpendicular bisector ran parallel, now class,
0.
0 points. Any other possibilities, back to Audrey? Good, if you were to do basically the same thing, but slide it here so that the 2 points were on opposite sides the same distance each time, so that your perpendicular bisector coincided, then you would get infinite points of intersection, wouldn't you? They would continually intersect. Are there any other possibilities besides missing, connecting once, or coinciding for infinite points? Nope, because 2 lines can't intersect a second time unless they coincided. So there's all your possibilities. Do you see the difference between 1 and 9? In 9, I had the freedom to position my points or my angle. I could have moved the angle around, I suppose, however I wanted. Whereas in the first problem, they told me where the points had to be, so it limited how many possibilities I could have. Questions on this?
Easy.
All right, so let's practice some of these. Set your books aside. I don't know that I'd close them unless you're good at finding stuff again, but you just set them off to the side. Just have some paper out. We will get back to the books momentarily. I want you to find the locus of all points that are equidistant from 2 given points and also equidistant from 2 parallel lines. And if you feel like this sounds familiar, it should. Your answer will be the number or numbers possible and a sketch for each one of them. All right, Quentin, what possibilities or possibility did you think of?
1 point.
1 point? Was that the only one, or did you have something else?
Something else.
Okay, what else did you have?
Infinite points.
Infinite points, okay. Anything else?
0 points.
0 points. Anything else? All right, Quentin had 0, 1, infinite. How many had those same possibilities? Did anyone have any different possibilities to add? Did anyone have a couple of those, or maybe one of those, but you didn't have all 3 of those? Okay, let's think through 1. That's the most natural, right? You've got your 2 parallel lines. Of course, that locus is going to be the straight line parallel to the given lines midway between them. And then your 2 given points. Now, if the 2 points were on the line, like we saw before, or, really, even if they're not, that perpendicular bisector of the line segment that would join the points still produces 1 point. But because the points could be anywhere, Quentin, I could position those points so that
They're not on the line. Or they're off of the line.
right, but again, I can move those points. However, let's put it this way. You said you had infinite. How did you make that happen?
I put 1 point on the line and the other point on the other line.
Okay, he put 1 point on one line, 1 point on the other. And so obviously when he does the perpendicular bisector of the lines that would join the point, they're going to coincide. Really, as long as they were equally spaced, however you did it, there would be a coinciding, and hence infinite points. And then for 0, what did you do?
We didn't say specifically that the points had to be on the line, so I just put 2 points wherever.
Okay, just 2 points wherever. Well, I kind of did that
Or
here.
else.
But you have to put them not just wherever, but wherever such that the...
Line would be parallel.
Right, so that this perpendicular bisector locus line runs parallel to the other. So, again, as long as they're kind of a vertical stack this way, then your perpendicular bisector will run parallel to the other, never intersect, and that's how we get 0. So how many, you said you got all 3 of those exactly? All right, and then Genesis, you said you were missing 1 or 2 of those? Which one were you missing? The 0, does that make sense if the points are down here? Again, or even truly, even if they're 1 here and 1 here, if they're just not equally spaced out, that other locus is going to just miss, isn't it? All right, questions at all on this one? All right, let's go on to another one. Write this one down if you would. I want you to find the locus of all points. First of all, a given distance from a given point. A given distance from a given point. All points, a given distance from a given point, and also another given distance, meaning it doesn't have to be the same distance, though I suppose it could be, another given distance from a given line. So we want all points that are a given distance from a given point, and also another given distance from a given line. You ever pull a hangnail, it bleeds like crazy, and you ask yourself, how could somebody as smart as I am be so stupid as to pull a hangnail, knowing darn well what's going to happen? I know it's going to bleed, and it's going to hurt, and it's going to get infected, and it's going to swell, and it's going to be awful, but I still do it. Hey. Think of another possibility. All right, Quentin thought he was done, been sitting here for a little while, and suddenly I noticed him reach down. He's like, work on something else on his paper, so he thought of something else he could do. I'm going to start with the second locus. I'm going to start with the given distance, given line. Okay, so got a given line, and let's just say we've got this given distance. What would be all points this distance from this line? Audrey?
2 parallel lines.
Good. One on either side, right? That given distance away. So we'd find that given distance, and there's our first locus. Okay. And then we got that same given distance down here. All right, and there's that given distance. Okay, so there's our first locus, 2 parallel lines, given distance away on either side, parallel to the given line. Then we've got our second locus, given distance from a given point. Does the problem specify where the point should be? So I can put the point anywhere. Maybe Genesis, we could put the point above the line, okay? And it also says another given distance. Well, that doesn't, how big should it be? Show me with your fingers or your hands how big of a distance you want. Because it says another given distance. So I don't have to use this distance. I'm going to use some other distance. How big do you want the distance to be? As far as on the chalkboard for demonstration. Smaller? So maybe a little bitty distance. Maybe we'll call it d prime for distance. Okay? So if I have this little bitty distance, how many points satisfy both requirements? Well, not 2. It's a horrible circle, I know. But how many points are both equidistant from the given line and this distance from that point? Only this one point of tangency, right? So I could get 1 point if my circle locus is tangent to only one of these lines. How many have 1 point as a possibility? All right. But there's other ways in which I could draw the picture, right? I could either move the point or I could make the distance different. What's another possibility, Ethan?
Moving the point
Moving the point where?
on the center line.
Okay, if I were to move the point on the center line, for instance, and I were to have this distance d prime, now how many points?
0.
0. How many had 0 as a possibility? The circle, after all, doesn't have to touch either one of these lines. The same thing would have happened if it had been down here, right? It could have just totally missed both of them. All right, do we have another possibility here, Kendall?
If the point is on the center line and the distance is the equal distance from line.
Oh, so you're saying if d prime happened to actually be equal to d, and this were on the center line, then when I draw this distance d prime, then I'm going to get 2 points of intersection, right? Because it's going to wind up being tangent at both of them. By the way, the same thing could have happened if Genesis's point had been just a little higher, right? That same point just a little bit higher, even if it's the same distance d prime, I still wind up with 2 points of intersection, don't I? All right, are there any other possibilities between 1 being tangent to 1 but not the other, 2 either intersecting one line twice or being tangent to both, or none, just missing both lines completely? Quentin?
4.
4. How would you manage 4?
You put the point on the given line, and then you make the distance bigger.
All right, I'm going to give myself a little bit more room here. Of course, lines can be extended indefinitely. And technically, Quentin, even if the point wasn't on here, right? If it was just in some way, maybe in between them, and the distance was sufficient that when you drew your circle, it happened to cut one line twice and the other line twice. You could get 1, 2, 3, 4 different points of intersection. All right, does anyone have anything other than 0, 1, 2, or 4? Audrey, you have something. How in the world would you manage 3?
You get it above the line on one side and then to touch the line.
Ah, so if the point were maybe, let's say, in between here, and the distance were just right to be tangent to 1, but such that it would cost the other twice. So you could get 0, 1, 2, 3, or 4 points. All right. Did anyone get anything else besides 0, 1, 2, 3, or 4? All right, that's all the possibilities there are, right? Because one line can only cross twice, max, right? So the max is going to be 4. The minimum, of course, would have to be 0. How many had all 5 possibilities? Audrey, you did. How many got 4 of the 5? There's only one that you missed. All right, which one did you miss?
The 3.
The 3. That's the hardest one to think of. Missed the 4. So you thought of the 3 and you missed the 4. Wow, I'm actually surprised.
3.
You missed the 3 as well. Again, I think that's the hardest one. How many did you miss?
I misread the problem, and so it's
Okay. And then Genesis?
3.
You missed 3 of them, or you missed the 3 possibility? Okay, so you got the 0, 1, 2, and 4, and just that 3 possibility. All right, questions on it now that we've seen it. Are you beginning to see how to think through all possibilities? Let's do one more, and then we'll be done for today. All right. The locus of points, locus of all points that are equidistant from 2 parallel lines, equidistant from 2 parallel lines 2 inches apart, 3 inches apart. I can't read my own writing. All right, all points equidistant from 2 parallel lines that are 3 inches apart and 2 inches from a point on one of the lines. The locus of all points equidistant from 2 parallel lines 3 inches apart and 2 inches from a point on one of the lines. Trust we got our first locus, right? The third line parallel midway between them. I don't have any liberty here. My point has to be, class, on one of the lines. And the distance from this point is not any given distance I choose. The given distance from the point has to be 2 inches. Well, if the lines are 3 inches apart, how far away from, say, this line is my locus?
1.5.
1.5 or 1.5. So if I had a 2-inch distance, that's going to drop just below that, isn't it? So how many points of intersection, class? 2 points of intersection. Is there any other possibility besides 2? Genesis is 9. Genesis, what other possibility exists? Should change your mind. Okay, someone else? All right.
Could it be on the center line?
Well, it says on one of the lines, meaning the parallel line. So no, it couldn't be on the center line. Even if it were, you'd still get the 2 points. Do you see how because I gave you a specific distance, you couldn't just pick, right? If I hadn't told you, you could have shortened it and made it none. You could have made it just right to get 1, couldn't you? But you didn't have that freedom. I told you what distance to use. I even told you how far apart the lines had to be. If I hadn't told you that, well, maybe the lines are like 5 inches apart and then it misses, right? Or 4 inches apart, it just is tangent, right? But when the distances are specifically given, the more information you're given, the more restrictive the locus. Less given information, more possibilities exist. All right, you have no homework this evening, but I am going to give you 2 extra credit problems. Page 178, numbers 6 and 7. Okay, if you want a shot at some extra credit heading into your next test, page 178, numbers 6 and 7 are extra credit. We'll go over more of these in our next lesson and continue practicing with these compound loci. Have a wonderful rest of your day. You are dismissed.